So next, we're going to the third lecture, addressing structural failure in the Nigerian housing sector. And this lecture will be taken by Engineer Victor Raydon, the Chairman, CEO, Modern Tek'Nik Associations. Welcome, sir.
Good morning, ladies and gentlemen. Let me start stand on the existing protocol. But, however, I need to appreciate the following people. I appreciate the CEO, co-founder of Roomeo Construct Limited, Mr. Doyin Adewola. Thank you, sir, for giving me this privilege to share my real profession with you and with the Congress. I also appreciate the former Surveyor General of the country, Mr. Adewola. Well done, sir. I also appreciate my co-lecturer, the lecturer 1, lecturer 2. In fact, they made everything simple for me as a structural engineer. My name is Engineer Dr. Otumba Victor Omoredon. I'm a fellow of Nigerian Society of Engineers, a fellow of Nigerian Institution of Civil Engineer, a fellow of Institute of Management Consultant, and I'm the CEO of Modern Tek'Nik Associate and Resources Limited, a consulting engineering management consultant established since 1996. And by the grace of God, I'm 32 years in structural engineering profession, back to back. And at the same time, you know why I'm smiling? The structure there standing, very stocky structure. I'm the designer of that structure. And thank you very much, Ms. Adewola, for giving me the privilege to be of service to you and to humanity. When he said I was going to speak for 10 minutes, honestly, I begged him that he should give me more time. Because structural engineering is a case. It's a case in this country. If we don't address the issue of structural failure, in fact, I don't know what we are going to address. It's a very serious case. And I thank God that my architect here, they are always a project manager. Why? In the construction industry, the town planner is here, thank God. So we have sequence of design and sequence of construction. So everybody need to work together. But I need to start telling you the nitty-gritty of structural analysis and design before I can tell you what causes the structural failure. How do we address it? You and I know some of the causes of structural failure. So it's not me today that is going to tell you, but the problem we have in the country is our attitude. The developer, as the town planner has already said, towards achieving a stable, rigid, and serviceability limit state of structures. You and I need to abide with it. I will read, please. It is a rare and distinctive privilege to be here today to give a lecture on addressing a structural failure in the Nigerian housing sector. Therefore, it is worthy to know that engineering is development, and structural engineering is excellence in environment. but inundated with failure and collapses. I can state categorically without prejudice that engineering is taken for granted in today's world. Yet, man has not always had engineering as we know it. The history of civil engineering, structural engineering option, necessarily the history of modern civilization. Life today is so dominated by engineering accomplishments that it hardly noticed, almost like the air we breathe in. Whether the area of healthcare sector, transportation, education, agriculture, energy, manufacturing, entertainment, communication, and housing sector. It is engineering that has made the difference. Indeed, we made bold to say that engineering development is national development. Conceptual, structural design, and analysis. The basic objective of structural engineering analysis and design is to produce a structure capable of resisting or withstanding or apply loads without failure during its intended use or the lifespan. As if when you are designing a structure in the engineering sector, like this building is designed for a lifespan of between 25 to 30 years without failure. But is that what we are having today? The structural engineering analysis and design point of view is the methodical investigation of the stability, strength, rigidity, and stability of the structure. Three major aims of structural engineering design are: we have three aims of structural engineering design. The first aim is safety. The second one is stability. And the third one is economy. As a structural engineer and as a young graduate, the problem we are having on this is that some of us are overzealous. We are, get quick syndrome. Nobody wants to be a pupil engineer under, a well-established or a well-experienced engineer. Most of our engineers these days, by the grace of God, I think I have a lot of engineers under my tutelage. But some of them don't do that. They will just wake up because of the advent of technology. Some of the ITF students and copper that come to my office, I used to show them the scale rule I used in 1985. It's still with me. Architect, sir. Scale rule I used in 1985. And the tracing paper I used in 1985. They will just come with a laptop because they have this software. Computer, they are forgetting that the computer is garbage in, garbage out. Well, one of my workers is a master degree holder. He came, I gave him, that time I was designing Mabushi Ultramodern Market, close to Nest. I went out, I gave him an assignment. They say, when you are a resident engineer, you have to do a redesign. So I gave him 10 meters by 2 meters. And in slab design, 10 meters by 2 meters, that is the ratio Ly all over Ls. Ly is the longer span, Ls is the shorter span. So the ratio Ly all over Ls will give you 5. And when that ratio gives you 5, anything more than 2, that slab is designed as one-way spanning slab. But when the ratio is less than 1.5, you design that slab as two-way spanning slab. I gave this engineer an assignment, I left. Because they are waiting, they want to change, the architect, they are bound to review and review. So I gave him, I said, I'm coming. That was 2005, Mabushi Ultramodern Market. So when I came, the guy was sweating. Oh boy, how far now? Have you finished? He said, sir, I cannot find the value in the table. I said, why? He said, sir, I said, the moment is very high. I said, Let me see. He has been sweating. So when I came, I said, look, do you know what? And this is what is causing one of the failures. But I will go to it. So, when he divided the ratio, Ly all over Ls, he got 5 actually. But what is the maximum bending moment for a simply supported slab? The formula is WL squared all over 8. For some of you who are engineers, you understand? Actually, he got it. WL squared all over 8. But the L is the length. But it's WLX squared all over 8. LS is the shorter span. My engineer went and used Ly. So he now divide the intensity of the slab, multiply by 10 square, divide by 8. He couldn't get the moment in the value of the table. So he was struggling and sweating. This is one of the major problems. I'm speaking today to our young engineers, the builders, architects, especially engineers, that you need to be grounded in formulae and analysis. That's why structural, you need to, before you say you are a structural engineer, you might have done a lot of analysis, a lot of training and retraining. So that is one. And economy, when you are designing a house, you must consider economy. Our town planner made mention of economy, architect made mention of economy, but our own economy, we will have 3 objectives now. Safety first, stability second, then economy. The economy is that you have to think of the initial cost and the mobilization cost and all that material cost. You have to take care of that. Because when you are choosing your design, whether it could be timber or steel structures or concrete structures, you have to take economy into play. Then, objective of a limit state design against structural failure. The objective of a limited design is to achieve an acceptable probability that a structure will not become unserviceable in its lifetime. The condition of a structure when it becomes unserviceable is called a limit state. The most important of these limit states are the ultimate limit states. This is one of the problems, the ultimate limit state. If you don't want your structure to collapse, you have to stick and adhere to ultimate limit state design. And what does it say? The ultimate limit state is neither the whole structure nor any part of the structure should collapse under foreseeable overload. In this place, some of us, sorry, I won't mention one category of one particular church. They normally buy residential buildings, especially story buildings, and they will convert it to church. I've been doing the conversion, but at the same time, I used to advise that the reconversion is not advisable. What am I trying to say? We have imposed load or live load. Live load or imposed load is the intended use of the structure. This is a residential building. The live load or the imposed load of a residential building is 1.5 kilonewton per meter square. We have church building, school building is about 3.0 kilonewton per meter square. We have lecture theaters, it's about 5 kilonewton per meter square. But these young engineers or some that are not rooted, when you say you do an imposed load of 1.5 kilonewton for residential, you now convert it to shopping mall. How will it stand? And many are doing like that. You will convert a residential building to a lecture theater, to hotel, then to classrooms. It work that way. So definitely you are subjecting such part of the components of the structure into collapse. Then we have serviceability limit state. The serviceability limit state deflection should not adversely affect the appearance of the structure. That is the deflection. When you enter any building, Like me as a structural engineer, if I enter any building, I first of all look at the beams. I will look at the beam. Beam is the lateral load. Column, vertical load. I will look at the slab. If you see anything that just cave in a little, that is a deflection. That means one part of that structure has already failed. When you see a crack, there are difference between, we have hair-like cracks. Some people time hair-like crack as structural cracks. Hair-like cracks is due to bad materials. When you use something like a mud and you are using it as a plastering material, you will see hair-like cracks. That is not a structural failure. But when you see structural crack along the beam, we call it shearing failure. I will come to that. No, when you see a column cracking or try to buckling, that is buckling failure, you will see it. Those are the some signs of structural failure. Then we have serviceability limit state of cracking. We have deflection because of time. We have serviceability limit state of deflection when a building deflects. Cracking, you will see it vividly. You see cracking, that is structural failure. Then there is also serviceability limit states of vibration. My office, I'm in the ground floor. It's two-story building. The person over me, when the children drop pin or something, you will know that somebody has dropped pin from upstairs. That is vibration. And that is a structural failure. You may know. It's a structural failure. Your building must not vibrate. Your building must not crack. So, and what causes it is inadequacy in sizing the size of the structure. When you say 150 mm slab, there is a particular length between 0 to 3 meters. You can have 150 mm thick of slab. But when your slab is going to 5 meters, 5.5 to 6 meters, and you are using the same 150 millimeter thick of, when you check your deflection will not be satisfactory. And that means that structure has failed. When you have a span of 6 to 7 meters, you are liable to use between 175 mm thick slab. Or when you have more than 7 to 8, that's why you see government officials, government projects, they don't use solid slab as much. They use either clay pot or hollow pot or waffle. If you go to Federal Secretariat, you see waffle, 800 by 800, you see hole. That is waffle. You see clay pot or rib slab. Those are the ones that can make, when you have a larger span of between 7 to 8 meters, then you can use. But if you use solid slab of 7 to 8 meter span, you are likely to have a thickness of about 200 mm, and it's very heavy. Sorry, it's very heavy. So the serviceability of vibration should not be such that they cause alarm or discomfort in the structure. Other consideration which should be taken into account in the design of a structure is to avoid structural failure are fatigue, durability, fire resistance, water tightness, excessive noise, excessive gain or loss. Then I will jump this sequence. I want to go to structural failure and collapse because of time. What is now structural failure? Structural failure refers to the loss of structural integrity or the loss of load carrying capacity in either a structural component or the entire structure itself. Structural integrity and failure is an aspect of engineering that deals with the ability of a structure to support a design structural load without breaking or collapse. So a building failure occurs when it loses to perform its intended design function. That is when you now say a building has failed. So what is structural or building collapse? A collapsed structure is when internal load, there's difference between structural failure. If structure can fail, it will still stand. Part of it or the whole structure, it will still stand. But when it now loses its internal mechanism, the design, intended load and carrying capacity, we can now say a structure has failed. Then a structure collapses when internal load bearing structural elements fail. A building will collapse into itself and exterior wall are pulled into the failure structure. This can also be defined as a partial or progressive failure of one or more components of a building structure, which leads to inability of the building to perform its primary function: comfort, satisfaction, safety, and stability. Failure of building can be cosmetic or failure or structural failure. Then what are the causes of structural failure? Let me highlight it. One, defective design. I've said it before. When you have a defective design or poor planning, all this one, we architects, as some architects, they want to have, they say, iconic building. You would like to cantilever 8 meter or something. Then if you are not a structural man who is grounded with one design, if you go to a prison headquarters along Airport Road, 5-story building, I was the one that designed it 2005, commissioned by Goodluck Ebele Golanta. The boys, they refuse to, I cantilever 6 meter entrance canopy. They say it will not stay. I say, let them do it, I will stay under when they are casting. That I'm sure of what I've designed. So, all those things, if you give it to a structural engineer, he will just give you, maybe nowadays they Google. He said they will Google. I don't I don't know why somebody wants to Google and how many reinforcement or the cantilever they want to do. So, that is. So, loading conditions and the structural elements. 2, engineering error. 3, detailing error. Detailing error, iron bending error, carpentry error. Let me stress on this. A structural engineer may have a very fantastic design, but iron bender will mess you up. There's what we call containment of bar, anchorage bond stress. How do you contain your bar at the foundation? How do you contain your bar at the beam? How do you contain your bar at the column and your slab? So there is a formula for containing of bars. Like for a column, we call it 46 phi. Phi is the diameter of the bar. When the bar is 16, 46 times 16, you know how to anchor. Compared to a Y25, and you use the same maybe 600 anchorage, it will not stay. It will slide. So a structural engineer can design a very fantastic design. Iron bender will mess you up. If iron bender doesn't mess you up, iron bender will do a fantastic arrangement of bars and everything. Carpenter will mess you up. If carpenter doesn't support using marine board or good wood, by the time you are casting, the thing will collapse, and it will fail. And they will say maybe a structural design has failed or something like that. It's not. It's the carpenter that has already messed you up. Then, improper construction of structural elements and foundation particular. Failure to perform sub-bearing capacity. And by the geotechnical engineer. When I was designing this place, I asked my boss here, please, I need the report from geotechnical engineering telling me what is the soil bearing capacity to design my foundation. Foundation is the last job for you to do, but you have to collate all your load, and you have to have a geotechnical engineer. Okay, so failure to carry out material test. That's why I said maybe next time. Failure to carry out material test, cement, sand, gravel, mechanical, electrical material before usage. You need to test all these materials. Then failure to perform load test, concrete cube test. When you are doing a foundation or you are doing any part of the structure, you must test concrete. They call it cube test. You must test steel. We call it tensile test. You know, we normally test even cement, consistency of cement, sandiness of cement, initial and final setting time of cement, all those ones. Coarse aggregate, you test it. Fine aggregate, you test aggregate impact level, aggregate crushing value. All these things, bulk density of sand, bulk density of cement. How many of us are doing that before we do construction? We just use bucket and do mixed design and do the construction. That is why at times we do structural failure. Then error during construction. Then another one causes of failure is force majeure. Force majeure, unforeseeable circumstances, irresistible completion, act of God, natural disaster, firestorm, flood, governmental or social action, war, invasion, and the war that is happening in what is called is they are just buildings are just failing. The sandness and all that, they are just failing and all that. So infrastructure failure, transportation and energy. So let me round up, please. So we have five basic types of structural failure. Please, I'll round up. We have compressive failure, tensile failure, bending failure, shear failure, buckling failure. Then, what is the way forward in addressing structural failure? One, integrity test of all high-rise structures. You must carry out integrity tests of all high-rise structures. Two, identify and prosecute offenders. I've not seen people going to jail. People have not gone to jail because, like my brother mentioned, quack. We have a lot of quack. People find joy to employ quack instead of professionals. So if you prosecute and identify offenders, that one is one of the way forward. Overhaul and restructure Nigerian agencies and government ministries. Government agencies and ministries. Therefore, integration of governance of construction industry like Koren, Aken, Cobon, QSRBN, TPLN, RCN, Aken, and what do we call it again? These are the governments and professional agencies. ACON. We need to integrate these people and work harmoniously for structure not to fail. Then enforcement of laws and policies. Our town planner mentioned that we need to enforce law. Town planner, sir, I want to increase the GDP of your ministry with due respect. Apart from saying that it's only two-story building that we carry out soil bearing tests. Sir, with due respect, if one-story building has collapsed. There are some story building, even a bungalow, where the soil bearing capacity is low, is bad. Like Mashi area like Lagos, Delta, Bayelsa. It is, I'm advising we should extend the soil bearing capacity test to a story building instead of two-story building. So, in conclusion, let me read the conclusion. Now, I need like 1 hour. Nigerians, in conclusion, Nigerian workers in the construction site, some innocent petty food sellers, so traders, die when any structure fails or collapse. Also, workers are being killed, maimed, properties being destroyed in the collapsed structure in the Nigerian housing sector. Therefore, ladies and gentlemen, each time we hear of a structural failure, fellow Nigerians are killed, materials and financial resources are wasted, family and friends of victims are psychologically traumatized and emotionally tortured. The fact that we have not been directly involved or affected today by the structural failure of a building is not a cogent reason for us, players in the construction industry, not to take appropriate steps and proactive actions to find a solution to structural failure in the Nigerian housing sector. It is regrettable that more and more structures are failing and consequently collapsing all over the country and in the Nigerian housing sector, despite the robust standards, specifications, regulations, and laws put in place by the federal government of Nigeria and our agencies and other professional bodies in the country. Apart from some very rare cases of acts of God, force majeure, Most cases of structural failure through building collapse are majorly caused by man-made. By following all design steps and precautions, hiring of certified professionals in both designs and constructions, adherence to specifications, standard and compliance in the building code, code of practice in engineering, synergy among professional bodies, and more importantly, identification and prosecution of offenders, I can genuinely guarantee you to a very large extent that structural failure cases in Nigerian housing sector can be drastically reduced, if not totally eradicated. Thank you so very much for having me.